Hello, we will now study about the application of definite integration. And in that application, the first application is area under the curve. Let us start with what is definite integration and what is its application of finding area under the curve. Supposedly we have the question is find the area under y is equal to 2x plus 3 from x is equal to 0 to x is equal to 4. Now this is a very simple question and we'll just quickly draw the diagram for this. Y is equal to 2x plus 3. It would look like this. This line is y is equal to 2x plus 3. We know this is a straight line. It's a linear equation. And when x is equal to 0, y is equal to 3. So I draw it here. And then with x is equal to 1, y will be 5, x is equal to 2, y will be 7 and so on. We want to find out from y x is equal to 0, x is equal to 0 is this. 2x is equal to 4, let's say x is equal to 4 is this. So this area is what we want. Area under this curve from x is one point to x is equal to other point. How can we find out the area under this curve? We will find out integration of y into dx from x is equal to pehla value, first value is 0, to x is equal to next value is 4, and this is equal to area. So area is equal to integration of 2x plus 3 dx from 0 to 4. This is equal to integration of 2x, 2 is constant, x, integration of x is x square by 2, 2 to cancel x. I hope there is no problem with this. Integration of 2x is x square, because integration of x is x square by 2, 2 will get cancelled, we will have x square here, plus 3, integration of 3 into dx is 3x. From 0 to 4, we'll put 4 and then we'll put 0. So we'll have this is equal to 4 square. Instead of x, I am putting 4. (16 plus 12, 28 minus 0 is equal to 28. This is how we can find out the area under the given curve using definite integration. We'll solve 3 more problems or 2 more problems like this. I hope you understood this. Let us now solve this problem. We have y is equal to x square plus 3x plus 4. And the area to be found is under this curve from x is equal to 1 to x is equal to 5. So I'll just do one thing. I'll draw a diagram. I'm not sure this diagram will be exact, but I'm drawing a rough sketch of some kind. So I'll draw something like, maybe this is the curve, and from x is equal to 1 to x is equal to 5, and this is the area. How can I find out this area? The formula is obviously simple. Area under the curve is given by y dx from x is equal to first value to x is equal to last value. So this is integration of x square plus 3x plus 4 into dx from x is equal to x is equal to 5. This is integration of x square is x cubed by 3 plus 3x square by 2 plus 4x from 1 to 5. So we'll put 5 here first. So it is 125 upon 3. 5 is a cube plus 3 into 5 square. 3 into 25. 75 upon 2. Plus 20 minus in bracket put 1. So it is 1 by 3 plus 3 into 1 square. So 3 into 1 is 3 upon 2 plus 4. Now if you solve this further it is 125 by 3 minus 1 by 3 is 124 by 3. If you get a division, great. If not, we can just find out the answer, leave it as it is. So the next step can be the final step, and we'll get the answer is equal to 124 by 3 plus 72 by 2 plus 16. 72 by 2 is 36 plus 16 is 52, and whatever be the answer of this, you can get it. Or we can, leave it by 3 or something like that. This is how, this is not the point is here. This is how we can find out the area under a given particular curve. I'll solve one more problem and then we'll move on to the next topic of discussion. Find the area under the curve. Find the area under the curve for y is equal to sin x from x is equal to 0 to x is equal to 2 pi. Or sometimes it is given, find the area of the under the curve y is equal to sin x for the entire cycle, one cycle. Now what will happen, please kindly pay attention to what I am saying now. The curve y is equal to sin x is like this. This is a sine curve. The value of at x is equal to 0, the value of sin x is y is equal to 0. At x is equal to pi by 2, the value of sin x is sin of pi by 2 is 1, so this is 1. At x is equal to pi, the value of sin x is sin pi is 0, so it is 0 again. At x is equal to 3 pi by 2, which in degrees we can call it 270 degree, and in radians or in circular angle it is pi, so it is 3 pi by 2. So at 3 pi by 2, the value of sin of 3 pi by 2 is minus 1, so y is minus 1. And at 2 pi, sin of 2 pi is 0, so y is equal to 0. After that, this is called as one cycle, because the same thing will continue after this. If you pay attention to this, the same thing, now after this, the same thing is going to happen. And so on. The same cycle will be repeated again and again. It's like a cycle. We have a bicycle, one wheel is one complete rotation is one cycle of the wheel, and the cycle rotates, repeats itself continuously. So this is self-repeating cycle. This entire thing is called as one cycle. So in this one cycle, if we take from 0 to 2 pi, the problem is, please pay attention to this, from 0 to 2 pi, the value of y is positive and the value of y is negative here. Everything perfectly matching with each other. If we take this part and we take it here, everything will perfectly match, and plus y and minus y will cancel out each other. So the entire area will come out to be 0. We just have a quick check about what I am saying. Please pay attention to this. I am saying, if I say from 0 to 2 pi, integration of sin x into dx is equal to, integration of sin x is minus cos x from 0 to 2 pi. So this comes out to be minus cos of 2 pi minus cos of 0. Cos of 2 pi is cos 0 is 1, but it is minus 1 here. Minus plus into cos 0 is 1. So this is minus 1 plus 1 is 0. So the area comes out to be 0. But we know area cannot be 0. There is area occupied here. It is happening because this area is coming out to be positive. And because every value of y here, sin x, is negative here. So this entire area for this range comes out to be minus. And this plus and this minus is getting cancelled. That's why the answer is coming out to be 0. You can see this. So what should I do? The answer is very simple. We'll convert this entire thing into a problem where the area comes out to be positive. And I will just write one line. Total area is equal to multiplied by area from x is equal to 0 to x is equal to pi. from x is equal to 0 to x is equal to pi. So x की value 0 to x का value pi, this to this area, the same area is here, just it is negative, not negative, it is downwards because the y value is negative here. So what we will do is we will find out this area and we will just multiply that area by 2. So the area A is equal to 2 into integration of 0 to pi sin x dx. This is equal to 2 into integration sin x is minus cos x from 0 to pi. This is equal to 2 into minus cos pi minus cos 0. This comes out to be 2 into bracket minus cos pi. Cos pi is minus 1. Minus of minus 1 is plus 1. Minus minus plus cos 0 is also 1. So this comes out to 2 into 2 is 4 square units. This is the entire area. So now we have to have that sense as to in which problem we can simply put this value as lower limit and this value of higher limit and solve the problem. But in this case we see that we cannot use 2 pi as it is here, but we will have to convert this into two half problems, solve one and then multiply by 2. This is the peculiarity of y is equal to sin x. If you put y is equal to cos x, the same thing will apply, same logic will apply. So we'll have to be careful about solving these problems. But these are not far too many problems. There is one sin x kind of problem like this, and the second one which is also to be solved using the similar logic. I will solve the second one as well, and then we'll stop with this and move on to the next type of problems in this chapter. I hope you are getting this. I hope there is no problem.